Hi everyone, it's Math with AUB. I have selected some questions regarding hyperbola when its center not at origin, how to find the elements. First of all, how we can classify or recognize the equation is given, it is equation of hyperbola and center not at origin. Look at this, x square, y square, one positive, one negative, hyperbola, and look, x power 1, y power 1, both are present. If any is present, then center is not at origin. Look at this, x square, y square, with alternate symbols, with changing symbols, positive, negative, it's hyperbola, x power 1, y power, any is present, in that case both are present. Similarly here, x and y both are present in center, not at origin. In case of ellipse, hyperbola and circle, if the term involving x power 1, y power 1, either of them or both of them are present, center not at origin. If x power 1 and y power are missing altogether, then center at origin. In case of ellipse, hyperbola and circle, let's see how to find its center, semi-transverse axis and eccentricity and coordinates of foci. Equation number 1 is 4x square minus y square negative 8x negative 2y minus 1 is equal to. Make x terms perfect square as well as y perfect square. Make them perfect square. Transform them in such type of equations, x minus h whole square over a square minus y minus k whole square over b square is equal to. That is the standard equation of hyperbola having transverse axis along x axis, center at hk. Having transverse axis along x axis, center at hk. We have to transform this equation into this by making x terms perfect square as well as y terms perfect square. Let's see how. Collecting the like terms, 4x square and 8x term having x here minus y square minus 2y minus 1, making the coefficient of x square and y square 1, 4 common, x square minus 2x minus 1 common, we have y square plus 2y, shift 1 there. Look at this, we can easily hunt what is where the deficiency, what sort of deficiency it is. X square minus twice x into 1, second term must be 1, so add square of 1 as well as subtract. Okay, cool, it's perfect square now. X minus 1 whole square. What about this? In the same token, y square plus twice y into 1. There must be 1 square, add and subtract, it's equal to 1. Now, it is a perfect square quantity as well. Sum them up, it must be x minus 1 whole square, x minus 1 whole square. Square of 1 is 1. Don't forget to multiply 4 throughout. Minus, here, it is the perfect quantity of y plus 1 whole square. Square of 1 is 1 is equal to 1. Okay, cool. Multiply 4 throughout. We have 4 times x minus 1 whole square minus 4. Okay, there must be a symbol minus y plus 1 whole square minus plus 1 is equal to 1. Shift for minus 4 and 1 on the right hand side. Now our question is taking the shape of this one. 4 times x minus 1 whole square minus y plus 1 whole square is equal to 1. It will become positive 4, it will become negative, cancelled out. We have 4 times x minus 1 whole square minus y plus 1 whole square is equal to 4. There we need 1. Dividing by 4. Divide by 4. Divide by 4. We have x minus 4 times x minus 1 whole square divided by 4 minus y plus 1 whole square divided by 4 is equal to 4 by 4. Cancelled out. Cancelled out. So we have such type of situation here, that is x minus 1 whole square over 4. 4 can be written as 4 cancelled out. Nothing remains, there is 1 square minus y plus 1 whole square. Instead of 4 I can write 2 square. Now look at this one, compare, this is our center, oh, compare with this one, like center of circle, center of hyperbola is, change the symbol, negative 1 take positive 1, positive 1 take negative, it is the center of this hyperbola, here on comparing, a is equal to 1 semi transverse axis, b is equal to semi conjugate axis, a and b. For coordinate of foci we need c as well. C is given by a square plus b square. So we have 1 square plus 2 square. C is equal to under root 5. C is equal to under root 5. C is equal to under root 5. Now let me jot all these elements together. Center is mine 1 minus 1. 1 minus 1. For coordinates of foci, center plus minus C. Center plus minus C. Our center is 1 minus 1, our C is root 5. Our C is root 5. A question arises where we have to add either both coordinates x and y or either of them. Look at this. Transverse axis along x-axis, transverse axis along x-axis. We have add this as well as subtract in x coordinate according to transverse axis. 1 plus minus root 5 and minus 1. These are the coordinates of our foci. And next element that we are asked, eccentricity. Eccentricity is very simple. It is given by C over A. C is root 5 and A is 1. A is 1. Look at this, it is greater than 1, and eccentricity of hyperbola is always greater than 1. Is always greater than 1. One can check all these elements, they are present here written. Okay, cool. Moving to question number 2. Almost replica of this one, but transverse axis along y-axis. Transverse axis along y-axis. Let me raise this first. Question number 2 is 16y square minus 9x square minus plus 36x plus 64 minus 116 minus 116 is equal to 0. Is equal to 0. Find the coordinates of center, foci, semi-transverse axis and eccentricity. Let me write 16y square minus 9x square plus 36x plus 64y minus 116 is equal to. Okay, cool. Collect the like terms to make them perfect square. 16y square plus 64y minus 9x square plus 36x. Shift 116 constant term over there. Make coefficient of y square positive one taking 16 common. Y square plus 4y. Okay, cool. Taking 9 common, making coefficient of x square 1. X square minus 4x is equal to 116. Now completing the square. Y square 4 can be written as twice y times 2. 2 to the 4. That's our second quantity. The square of this quantity must be present there. So that is the deficiency. Add as well as subtract. 2 square add as well as subtract. Okay, cool. Now it's the perfect square quantity. Y plus 2 whole square. In the same token, what about this? Minus 9 x square 4x can be written as 2 times x times 2. That's our second element, our second term. A minus b whole square. B is 2. There must be 2 square. Add as well as subtract. A is equal to 116. Okay. Merge them. It is the perfect square of y plus 2 whole square. It is x minus 2 whole square. Don't forget to multiply 16 throughout. In that case, 9 throughout. We have 16 y plus 2 whole square. This one, negative 2 square means 4 minus 9. Merge them. X minus 2 whole square minus the square of 2 is 4 is equal to 116. 16 multiply throughout. 16 y plus 2 whole square. 16 for the 64 minus 9 times x minus 2 whole square minus plus 9 for the 36 is equal to 116. So shift 64 and 36 over there. What we have, let's see and find out. 16 y plus 2 whole square minus 9 x minus 2 whole square is equal to 116 plus 64 minus 36 minus 64. 16 y plus 2 whole square minus 9 times x minus 2 whole square is equal to, what remains here? That is the ideals, especially mostly the product of these two number is present here. 16 9 the 144. There must be, mostly there lies the product of 16 and if you can calculate you will get 144. Instead of 144 we need 1 divide by 144. Sorry, 144. We have 16 times y plus 2 whole square divided by 144 minus 9 times x minus 2 whole square divided by 144 is equal to 144 divided by 144. What we have here, it will become 16 and it will become 9. It will become 9. Okay, cool. Let me write here y plus 2 whole square. Instead of 9, I can write 3 square, and here x minus 2 whole square. Instead of 16, I can write 4 square is equal to 1. So the coordinates of center are center. First we have to write x coefficient, x term. Minus 2 take positive 2. Positive 2 take negative 2. That's coordinate of center. That's coordinates of center, and they are present here. What about foci? For foci we need c. C is equal to a square plus b square, or c. A square means that's our 9. B square means 16. So C is 9, 16, 25. So C is 5. C is 5. Now question arises where we have to add. That is the formula to find foci. Center plus minus C. Center plus minus C. Center is 2 minus 2 and value of C is 5. Now question arises where we have to add. In transverse axis. In transverse axis. Transverse axis along y axis. In y coordinate we have to fix this one. 2 minus 2 plus minus 5. It will become 2 minus 2 plus 5 is 3, or 2 minus 2 minus 5, it will become minus 7. These are the coordinates of center. These are the coordinates of center, and semi-transverse axis is equal to 3 and semi-conjugate axis is equal to 4. What about eccentricity? Finally, E is equal to C over E is equal to C over E, or C is 5 and value of A is 3. That's greater than 1. That's greater than. That is our answer in that case. That's our semi-transverse axis, semi-conjugate axis, coordinates of center, coordinates of foci, and the rest. Okay, cool. Moving to question number final. Question number final. That is our question. 9x square minus. It is almost same. In that case, transverse axis along x axis because x is positive. In that case, y square is positive, transverse axis along y axis. In that case, x square is positive, transverse axis along y axis. Similarly, this is a question almost replica of question number 1. For your practice, let me solve this as well. Okay, cool. 9x square minus y square minus 36x minus 6y plus 18 is equal to 0. How to handle this? Let's see and find out. We have 9x square minus y square minus 36x minus 6y plus 18 is equal to 0. Collect the like terms, make them perfect square. 9x square minus 36x minus y square minus 6y. Take 18 on the left hand side. Making the coefficient of x square positive one, taking 9 common, x square minus 4. Here, take only minus symbol common, y square plus 6y is equal to negative 18. Negative 18. Perfect square, it can be written as a square twice x into 2. The second term b is 2. So we need the square of this one. Add as well as substitute. Okay, cool. What about this? Minus y square. 6y can be written as 2 times y times 3. The second term is 3. Square of 3 add as well as subtract is equal to minus 18. Okay, cool. Merge them, sum them up, shrink it, contract it. It is x minus 2 whole square. Square of 2 is 4 minus, shrink it. It will become y plus 3 whole square minus 9. Okay, cool. Minus 18. Now multiply 9 throughout. We have 9 x minus 2 whole square, 9 for the 36 minus y plus 3 whole square minus plus 9 is equal to minus 18. Look at this. Negative 36 plus, shift them on the right hand side. Whatever the result is, we have good idea about this. Y plus 3 whole square minus 18 plus 36 minus 9. Minus 18 plus 36 remains 18. 18 minus 9, 9. 9x minus 2 whole square minus y plus 3 whole square is equal to 9. I have already given you a tip. The product of this coefficient, this term and this must be present there. Whatever is with x square, coefficient of x square and y square must be, their product must be present there. Mostly 99% cases this thing is present here. Divide by 9. Divide by 9. We have 9 times x minus 2 whole square divided by 9 minus y plus 3 whole square divided by 9 is equal to 9 divided by 9. Okay, cool. So we have some sort of this sort of equation, x minus 2 whole square over 1 square y plus 3 whole square. Instead of 9, 3 square is equal to 1. Center, like center of circle, change the symbols. Negative 2 take positive 2, positive 3 take negative 3. Semi-transverse axis a is equal to 1 without square. Conjugate axis along y axis it is 3. Find c for the centricity. It's given by a square plus b square. C is equal to 1 square plus 3 square. So c is 1 plus 9. C is root 10. C is root 10. How to find foci? Foci is given by center plus minus c. Our center is 2 minus 3. C is root 10. Root 10. Question arises where we have to add transverses along x-axis. We have to add as well as subtract for foci, both coordinates of foci in A. 2 plus minus under root 10 and minus 3. What about eccentricity? E is given by c over A. What is our c? Root 10, and our A is 1. It is obviously greater than 1. Eccentricity of hyperbola is always greater than 1. These elements are written, one can verify. It's my tiny effort to quench your thirst in the conic section. It's all by itself. Next.